Hello, I'm an old guy and I do maths. Today we're going to look at turning point form and how we graph it. And here we have an example of turning point form. Y equals x plus 3 all squared plus 2. This is the telltale sign that you're dealing with turning point form. You have an expression here squared and another number here. Okay, now it's very, very simple. Initially anyway. So how do we find the turning point of the graph that this equation generates? Well, we make this bracket equal 0, which is very simple. X plus 3 equals 0 means that x must equal negative 3. That's going to be our x-coordinate of the turning point, and you can see that down here. So that is 3 units to the left from the origin, so 3 units, let me get that into frame, 3 units in that direction, and if we make this whole expression equal 0, we can put our thumb on it, or we can just ignore it, or we can make x equal negative 3, whichever works for you. We get a simple expression y equals 2. That is the y-coordinate of our turning point, and that is 2 units up. And that's all there is to finding the turning point from this form. It's very, very simple. Now, we do have some other things to do if we want to graph this parabola fully. We have to find this point, the y-intercept, and there are 2 ways of doing that. I'm going to start with the recognized way, which is slightly longer, which is this piece of work down here. What I've done is I've taken this equation and I've simply expanded it. So this is a perfect square, and if I put my finger over 2, you can see how this expands. X squared plus 6x, 2 times 3 times x, plus 3 squared, 9. Now, if that's mysterious to you, have a look at my video on perfect squares and their expansions. It's very simple. It's just a mathematical pattern. Now, we're not done because we expanded this, but we also have to add 2 to it. So we wind up with x squared plus 6x plus 9 plus 2, which, when we tidy it up, gives us x squared plus 6x plus 11, and we know that this is the y-intercept, because if we make x equal 0, y will equal 11. That gives us this point here, which is 0, 11. Okay, so that's nice and straightforward, I hope. There are a couple of other things to note. This parabola does not go through the x-axis, so we haven't had to find x-coordinates, and that also coincidentally means that there are no solutions for x for this equation. And this doesn't mean that the equation doesn't exist, it doesn't mean that the graph doesn't exist, it simply means that it does not touch or go through the x-axis. So what we're going to do now is we're going to have a look at a similar equation that does. And here we are. One subtle difference. Instead of this being plus, it is minus. And so to speed things along, I'm not going to go through how we find the x and y coordinates. If it's a little bit mysterious, just scroll back through the video and have a second look. The x-coordinate of the turning point is negative 3. We make that equal 0. The y-coordinate is negative 2. I take this equation and I expand it, as I did last time, and I get x squared plus 6x plus 7, is going to be my y-intercept. Right, well, it's pretty obvious that this thing hits the x-axis twice. So now we're going to figure out what those intercept coordinates are. And this is how we do it. There are a couple of ways. There's a fast way, which is that we simply rewrite this equation into this form. Now, how do we do that? Well, we open up a pair of brackets, slightly wider than this pair of brackets, and we put x plus 3 into each of those brackets. Now, x plus 3 is the square root of this expression here. X plus 3, x plus 3. Then we take the square root of 2, which is simply root 2. We just write it as root 2 as a surd. And what we want is we don't want 2, we want negative 2, which means that we're going to have to multiply negative root 2 by positive root 2 to get that outcome. So in factorized form, this looks like this: x plus 3 minus root 2, x plus 3 plus root 2. And if we make each of these brackets equal 0, what we get is we get x equals negative 3 plus root 2, or x equals negative 3 minus root 2. And those are our coordinates up here, our x coordinates of the intercepts. So it's a bit difficult to write it in here, but I'll try. So this is negative 3 minus root 2, 0. Just get those expressions together. And this is negative 3 plus root 2, 0. Okay, I hope that makes sense. Now, if that was deeply mysterious to you, you can use the quadratic formula, which is this. There's a separate video on this. I simply put in the values from, let's get that into focus. I put in the values a, b, and c from this equation. B is 6, so it's negative b, so negative 6. A is 1, so that's 2 times 1. And c is 7, so b squared minus 4 times 1 times 7, which I have here. And when I tidy that up, I get negative 6 plus or minus root 8 over 2. I can simplify this surd to 2 root 2, which I'll just do on the side here. So that is the square root of 4 times the square root of 2. And if that's difficult, it's my mantra. Go and have a look at my video on surds. Okay, we can tidy this up. We can divide through by 2. And what we get is 3 plus or minus root 2. That disappears, that becomes 3, that disappears. X is equal to negative 3 plus or minus root 2. So x is equal to negative 3 plus root 2, negative 3 minus root 2. Okay, that is how you graph quadratic in turning point form, one that does touch the x-axis and one that does not. Okay, I hope that was helpful. See you again next time. Bye-bye.